this is arithmetic, geometric, or it is neither. Okay. So the first thing you want to do is you want to take your second term, or what we call, so this is A1, this is A2, this is A3, A4, because it's the first number in the sequence, second number in the sequence, third number in the sequence, and fourth number in the sequence. So what we can do is to test whether it is a geometric series, we can take our second term and divide it by our first term. So our second term is 12 divided by 8. And then we get, well, this is equal to 4 times 3, and this is equal to 4 times 2. And we can cancel out the 4's, and this becomes 3 over 2. So the common ratio between the second and first term is 3/2. So to test if this is a consistent common ratio, I'm going to take the third one and then divide it by the second one, the third term and the second term. So I'm going to do 18 divided by 12, and I get 3 times 6 and 2 times 6. Cancel out the 6's, and I get 3 divided by 2. So you can see here what this means, or what this tells us, is that to get from 8 to 12, I multiply by 3 divided by 2, and to get from 12 to 18, I multiply by 3 and then divide by 2. So they have a common multiplicative number, so it would be like I times 3/2 and then times 3/2. And so you can see here that they would have a common ratio. You guys wrote down, I believe, the common ratio of a geometric series. You guys wrote down that in your notes. And so you wrote down that A of n is equal to A1 times r to the n minus 1. So for example, if we were to write an example of an equation for this, this would be equal to A1, which is the first term, which is 8. And then r is your common ratio, or 3/2, n minus 1. So this would be your equation. So if they asked us to write an equation for the geometric series, we could just go ahead and write that. In this case, you can tell that it is a geometric series because it has a common multiplicative number. So again, if I multiply by the same number from the first to second term, second to third term, third and fourth, and it just keeps going the same number I could just multiply to get to the next term, then that's what we call a geometric series. So that's multiplication that they have in common. Okay, so the second idea, or what we can test here, so the second problem here is 8, 16, 24, and 32. So in this case, we can test the same thing. We can do A2, which is the second term, divided by the first term. And we get 16 divided by 8, which is just equal to 2. We can do A3, which is now we're testing the next two terms. 24 divided by 16. They have 8 in common, so it would be 3/2. And you can see here that the first common ratio is 2, while the next common ratio is 3/2. So this is not a geometric series. This is not a geometric series because to get from the first to the second term, I multiply by 2, but to get from the second to the third term, I have to multiply by 3/2. So to here, it's multiply by 2, and then from here, it's multiply by 3/2. So because this is not the same, where I am not multiplying the same number, it is not a geometric series, right? It is not a geometric series. So we can test whether it is an arithmetic series. Arithmetic series, all it means is, do I add a common number or do I subtract a common number? Okay, so arithmetic series, again, is just, do I add a common number or do I subtract a common number? So to test that, we could do A2 minus a1, and that equals 16 minus 8, which is equal to 8. Then I can do a3 minus a2, which is equal to 24 minus 16, which is also equal to 8. So you can see here that you can actually just add 8 each time to get a common arithmetic series. So in this case, we would say it is an arithmetic series. So again, arithmetic is just a fancy word of saying what they have in common is that you can just add a certain number to each term, and that is what they have in common. You just add 8 every single time to get to the next term. Okay, so we're going to show one last example here. One last example. Does anyone still need the second one, actually? So in this last one, we're just going to do both tests again. We're going to do a2 divided by a1, which is equal to 10 divided by 6, which is equal to 2 times 5, or 2 times 3. So this equals to 5/3. And then we have a3 divided by a2 is equal to 15 divided by 10, which is equal to 5 times 3, 5 times 2, and that's equal to 3/2. So 5/3 is not the same as 3/2, so this is not, so therefore it is not a geoseries. It's not a geometric series because 5/3 is not equal to 3/2. Then you could do a2 minus a1, which is 10 minus 6, equal to 4. And then you do a3 minus a2, which is equal to 15 minus 10, which is equal to 5. You can see it is therefore also not a arithmetic series. So it is also not an arithmetic series. So you would say it is neither. You could just say it is neither. That's fine.